3, 4 equals. 1, 2, 3, 4 equals. Then that means take 1 times 4 minus 3 times 2. So that equals 4 minus 6. Yep, so the determinant of this matrix is -2. And I don't have to find the determinant. All I have to do is put these straight lines next to it, and that's what I'm telling you to do. Why do we find determinants? You will see some of their uses. I probably won't show you exactly how they were discovered, because that is involved. But that's how you find the determinant of a 2 by 2 matrix. One more note before I do a 3 by 3, which I'm going to show you 2 ways to do, and they're both a little involved. Okay? No, it's a little weirder. You can only find determinants of square matrices. You can only find determinants of square matrices. Back in the day, they did not teach this until you got to college, and I walked into a linear algebra course, and all of a sudden I had to find the determinants of like 7 by 7 square matrices. Sometimes without a calculator. It was really crazy. And calculators couldn't do matrices back then. And we walked uphill barefoot through the snow both ways.
So it wouldn't have made a difference. What?
I was just saying it was I was just, exaggerating how hard it was back then.
It's like, I had to walk 10 miles just to get a cup of pudding.
Exactly. I was trying to make myself sound like Oliver Twist or something. Okay. I'm going to erase this one.
Oh no, I was using it as an example and I didn't. Never mind.
Sorry, can you get it from someone else?
I had it, it's just like, you can't read it. So I was looking at the book and it was so it was
I appreciate that.
It was
However,
clearly.
I need to go on to something that I don't think you'll be able to multitask through. Because I need to teach you 2 different ways to find the determinants of a 3 by 3 matrix.
I have one question.
Not yet, unless it's on what's on that board.
No.
Okay, then hang on to it, sweetie. I'll get to it soon. Okay, now, 3 by 3 matrices. There's 2 ways to do this. Just out of curiosity, who thinks they would learn it better if I put up like a formula with A, B, C, D, etc. like this, or if I did an example with numbers first?
Good
Example with numbers first?
No. A, B, C, D.
A, B, C, D would help? Da-da-da.
Yeah, A, B, C, D.
Okay, I'm going to go with the A, B, C, D one. Sorry, Rodney. You'll get to the example with numbers right after.
I like that better anyway.
Okay. All right. Give it a 3 by 3 matrix. Okay? Now I'm putting the absolute value signs so you know you're being told to find a determinant. Why do I do which part? Okay. Now, you can't really do it exactly like this, because you'd only get one diagonal and another diagonal, and that would miss some numbers, and a determinant does have to involve every number in the matrix. So here's the trick. You take the first 2 columns of the matrix, and you redraw them out here. So you take your 3 by 3 matrix, and you turn it into essentially a 5-column matrix. Okay? If you're using this method, I'll teach you a different method if you don't like this one. Most people tend to like this one better. Then you follow a similar pattern to what you did on the 2 by 2 matrix, but you have to do it 3 times. So what I'm going to do is I'm going to take the product of this diagonal, and I am going to subtract from it the product of this diagonal. So that will give me A times E times I minus G times E times C. Then, but wait, there's more.
But how does it work?
But how does it work? Then, I do the same thing 2 more times. I take the product of this diagonal, BFG, see I've gone outside my matrix, that's why I drew these columns, and from that I subtract the product of this diagonal, the second one going up from the bottom. So this becomes plus, let me do this in all in a consistent color. So this becomes plus, yeah, now this one's positive again. If they're going down, they stay positive. Plus BFG.
It looks like a Y.
Oh, I remember this too.
Good. Minus
I hate it.
HFA. Okay?
I really messed it up. I wrote it like over here, so it's...
Oh my lord. Okay, that'll be, yeah, it's hard to get this neat. Now finally we do this once more. We take this last downward diagonal that we can draw with 3 elements and make its product, and from that we subtract this last upward diagonal with 3 elements that we can make. So this becomes plus CDH minus IDB.
Are you switching the signs?
Yes, and we're alternating the signs, but here's the pattern to it, Sade. Also, if you don't like drawing these 3 gourds, hang on a sec, before you ask a question, let me say this. If you don't like drawing these 3 gourds, because perhaps it'll be messy, one thing you can do, Sade, here's another way to remember that. All the diagonals that slant down, you keep positive. All the diagonals that go up, you make negative, and then if you want, you can do it in any order you want to. You can do AEI plus BFG plus CDH minus GEC minus HFA minus IDB.
They're pretty much switching each row and each column.
If it's got a here's one way to do it, hopefully I'm confusing. If it's got a negative slope, you keep it positive. If it's got a positive slope, you make it negative. The ones going down are positive, the ones going up are, you can make negative. Isn't that confusing? Yes, Nimi?
I'm correcting you on something from earlier. For number 23, it's actually 0.9.
I'll be happy to take a look at that
It's in the answer.
soon. Okay?
No,
but not right now. But thank you. No, I'm
saying.
good. I'd love to. I'm happy to be proven wrong as long as everyone gets the right information. Okay. Remind me of that later. Okay. Let's do an example of this. Okay.